Hello dear friends, welcome back to my YouTube channel. Now in today's lecture, we are going to learn about the ionic bonding, or it is also known as an electrovalent bonding one. Now in the previous lecture, we have studied about the approach of the Cosell's and the Lewis towards the chemical bonding one. Now there you have studied that each and every atom try to gain the stability either by achieving the duplet or the octet one. Now on the basis of that one, we have introduced the new concept, that is the chemical bonding. Now here generally the bonding is considered in the form of ionic bonding and the covalent bonding one. Now here we are going to deal with the ionic bonding or the electrovalent bonding one. Whenever we are going to consider the ionic bonding and the electrovalent bonding, we have to consider one important term, that is nothing but the electronegativity. So we will first of all study what is the electronegativity. So just keep in your mind, electronegativity is one of the important terms, which means each and every atom have tendency to attract the electron toward itself one. Now that tendency or that capacity is generally known as electronegativity one. After knowing about the electronegativity, we are going to consider the ionic bonding one. So remember, the ionic bonding is generally formed in those atoms which shows the large difference in the electronegativity values one. So keep in your mind, this is very important point. Generally the ionic bonding observed in those atoms, okay, which have the large electronegativity difference, large electronegativity difference one. Okay. Now whenever there is a large electronegativity difference in between these atoms one, now generally the transfer of electrons takes place. Okay. Here whenever there is a large electronegativity difference, there is a transfer of electron takes place in between these atoms one. Whenever the transfer of the electron takes place, obviously each and every atom try to gain the stability either by achieving the duplet or the octet one. Okay. That means it depends upon how many electrons can be transferred by one atom to the another atom is generally depends upon your duplet or the octet one. Okay, you have studied the octet rule in the previous lectures one. You know that every atom try to gain stability by achieving the stable electronic configuration as like noble gases one. Okay, so this is the another important point while considering the ionic bonding one. It means very simple. Here, if the electrons transfer from one atom to the another atom, obviously the involving atom in the chemical bond transfer only that much electron which will complete its duplet or the octet in between that atoms one, as like the noble gases one. Any atom attain the duplet or the octet, it achieve the stable electronic configuration, as like the noble gas, or we will call it as an inert gas element one. Okay, so generally these elements shows the stable electron configuration in the form of a 1s2. Okay, that is nothing but your duplet, or it will achieve the octet one, that is NS2, NP6. So this is the octet one. Okay. Now here you have to remember one important thing. During the formation of your ionic bond, electrons transfer mutually between the two atoms one. Okay, the atom which lose the electrons here, one atom lose the electrons. Okay, now that atom is generally known as electropositive element. Electropositive element, and it have positive charge. Keep in your mind one. Okay, for example, if I am going to consider a general example, M is the metal, okay, or any atom which when lose its one electron converted into its ion 1 plus there will be the one electrons 1. Now this particular ion is known as an electropositive element 1. Other atom gains the electrons. Okay, now that atom is generally known as an electronegative element. Electronegative element, and it have negative charge 1. Okay, so this is the two important points. One atom during the formation of your bond 1 lose the one electron, while other gains that electron. Now for example, I am going to consider the simple general example. X in the gaseous state gains the one electron and converted into the ions X minus ion, okay, which we generally call as an anion 1, okay, as having the negative charge, while it is called as an cation 1. Okay, so as there is a formation of the two ions takes place 1. You know that whenever there is a opposite charge on the ions 1, it is the natural tendency of the atoms to attract towards each other 1. Okay, so here due to charge, it develops the electrostatic force of attraction. Electrostatic force of attraction, that is nothing but the attractive force between the two ions 1 due to their opposite charge 1, that is nothing but your electrostatic force of attraction, and this leads to the formation of your ionic bond 1, or it is also called as an electrovalent bond. We have considered the general example. So M plus as having the positive charge, having a plus charge, will attract the X minus, and this leads to the formation of your ionic compound, that is Mx, but here the M is having a positive charge, X is having a minus charge. To the two opposite charges there is a development of the attractive force, and that attractive force is generally known as an ionic bond 1. So in above all the discussion, you have to keep two things in your mind. The first thing is that these two combining atoms have the large electronegativity difference. Okay, they have the large electronegativity difference. Okay, and remember, they develop the electrostatic force of attraction. Electrostatic force of attraction, and that electrostatic force of attraction is nothing but your ionic bond 1. This is very important point. Now let us define the ionic bond 1. So here I have written the definition. It is very simple. This is nothing but the electrostatic force of attraction between the atoms by transfer of electrons due to the large difference in electronegativities. Now that particular bond is known as an ionic bond or the electrovalent bond 1. So this is the theoretical definition of your ionic bond 1. So let us again revise in short. a force of attraction between the oppositely charged ions, that is nothing but the electrostatic force of attraction between the atoms by transfer of electron. Transfer of electron takes place from one atom to the other atoms one. Okay, and that transfer of electron is due to the large difference in their electronegativity values one. Now let us consider the example. Now NaCl here and the calcium chloride. So these are the two particular molecules which forms the ionic bond one. Okay, now here sodium is having the electronegativity value 0.9, chlorine have the electronegativity value 3.0. okay, calcium have the electronegativity value 1.0, while again the chlorine have the electronegativity value 3.01. So obviously there is a large difference between these two values one, and hence these compounds are formed by the transfer of the electrons mutually one. Let us consider the formation of NaCl, how the ionic bonds is formed one. Now here let us consider the first of all the electronic configuration of sodium and the chlorine one. So the electronic configuration of sodium and the chlorine. Here sodium atomic number 11, its electronic configuration 1s2, 2s2 and 2p6, 3s1. okay, now chlorine atomic number 17, its electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p5. okay, now let us consider the valence shell. Here in the sodium atom, in the valence shell there is a 1 electron. okay, in the chlorine the valence electrons are 7 in its valence shell one. Consider the second point. The sodium atom having the electronic configuration. Okay, I will write it as an sodium 2, 8, 1, just electronic configuration. If it lose its 1 electron, okay, it will convert into the Na plus ion. Now its electronic configuration will become 2, 8 and its valence shell will become, okay, if I remove this electron, obviously its valence electron, its valence shell will have the 8 electrons one. So that I have written here, and 1 electron one, obviously. So here your sodium ion complete its octet, so it will become stable. Now exactly opposite, chlorine, its electronic configuration is 2, 8, 7, just I have written in this form one. So if this chlorine gains the 1 electron, okay, we are adding the 1 electron in the valence shell of the chlorine one. Okay, so obviously it will convert into the Cl minus ion. Its electronic configuration will become 2, 8, 8. So here chlorine also complete its octet. Here your sodium ion also complete its octet one. Okay, both these atoms complete their octet and become the stable, but they develop the opposite charges, and we know that if they develop these opposite charges, there will be the electrostatic force of attraction, and that electrostatic force of attraction between the oppositely charged ions are nothing but your obviously ionic bond, or you will call it as an electrovalent bond one. So obviously your Na plus ion plus Cl minus ion. Okay, so there will be the formation of your NaCl ionic bond between these two atoms one. Okay, that is Na plus or the Cl minus, and the bond between these two atoms are generally known as an ionic bond one. That's it. Okay, so this is the formation of your NaCl molecule, and there will be the formation of your ionic bond one. So after studying this particular example, again we will simply revise this definition. We know that electrostatic force of attraction between the atoms by transfer of electron, sodium lose its 1 electron, that electron is taken by the chlorine, So obviously there will be the opposite charged ions, and that opposite charged ions will show the electrostatic force of attraction, and their electronegativity values that I already told you, 0.9 and 3.0. so there is a large electronegativity difference, and that's why there is a transfer of electron takes place in between these two atoms one. Okay, so that bond is known as an ionic bond. Let us consider the second example, that is nothing but formation of your calcium chloride CaCl2 molecule. Now let us consider electronic configuration. Calcium atomic number 20, its electronic configuration will be 1s2, 2s2, 2p6, 1s2, 2s2, 2p6, 3s2, then 3p6, 4s21. Okay, now chlorine, again atomic number 17, its electronic configuration will be 1s2, 2s2, 2p6, then 3s2, 3p5. Okay, so I will write it as an 2, 8, 8, 2. Okay, while chlorine will have the electronic configuration 2, 8, 7. Okay, if I am going to draw the Lewis structure for the formation of this particular CCl2 molecule, it will be like this. Here calcium will be at the center, its valence shell have the 2 electrons, so I will show that 2 electrons in the form of cross one. Okay, the chlorine having the 7 valence electrons, so I will write the Lewis structure for chlorine atom like this one. Okay, so what happens here, calcium will lose its 1 electron to the chlorine atom and another electron to the another chlorine atom. Okay, so obviously there will be the formation of ion takes place, as this chlorine accepting the 1 electron, this chlorine also accepting the 1 electron, while the calcium losing its 2 electrons one. So calcium will have the 2 plus charge one, as it lose the 2 electrons, while chlorine have a minus 1 charge. Okay, as it's accept the 2 electrons. Okay, I will show 1 electrons of the calcium by the cross one, and these are the pair of electrons of your chlorine one. So there will be the obviously the attractive force developed between these two chlorine atom and the calcium atom, and that bond is nothing but your ionic bond or the covalent bond one. So remember, during this process these 2 electrons is lost by the calcium, so its electronic configuration will convert into the 2, 8, 8. So obviously octet will be completed by your calcium one. Now here there will be the 1 additional electron in each chlorine atom, so its electronic configuration. Okay, here we are going to add the 1 electron, so here its configuration will become 2, 8, 8. So chlorine also complete its octet, then calcium also complete its octet one, and that ions are stable, but due to these 2 opposite charges one, Cl minus and Cl minus. So due to the calcium having the 2 plus charge and the each chlorine having the negative charge, so there will be the formation of your ionic bond takes place one. So this is the another simple example regarding this. Considered the conditions for the formation of your ionic bond one. Now remember here, the participating atom must have large difference in the electronegativities one. Then and then only the ionic bond formation will takes place. So this is the first condition. Now in the second condition, we have to consider the one participating atom must have low ionization energy or ionization potential, so that we can easily remove that electrons from that atoms one. Okay, now what is ionization energy? You already know in periodic table. This is nothing but the amount of energy required to remove the most loosely bonded electrons from the atoms one. So this is nothing but the amount of energy which required to remove the electron. Third, the other participating atom must have high electron affinity, low ionization energy and high electron affinity. So what is electron affinity? So here electron affinity is one another important which you have studied in your periodic table. We know that this is nothing but the amount of energy released when an extra electron is added into the atom to form the ions one. So one atom must have high electron affinity while other atom must have the low ionization energy. These points are very important. They may ask you in NEET and JEE. Next, that we have to consider the way of involvement of ionic bond one. Okay. Now here in this way of involvement of ion, we are going to consider the different types of atoms. Okay. Only different types of the atoms can form the ionic bond one. We have studied the example, that is NaCl. Here sodium and chlorine. Okay. Second example that we have considered is CaCl2, calcium and chlorine. Okay, the atoms of these elements are the different one. So this is the way of involvement for the formation of your ionic bond one. Cl2 molecule will never form the ionic bond one because both atoms are the same one here. Okay, the involving atoms are the same, they will not form the ionic bond. The different atoms must involve to form the ionic bond one. Now the next important point that we have to consider while considering the formation of your ionic bond is nothing but the properties of the ionic bonds one, which is very important one. Just keep these properties in your mind. Here the first property that I have considered here is the bond always formed by the transfer of electrons one. Okay, so whenever the ionic bond form, there is a involvement of transfer of electrons from one atom into the another atom. Several times we are repeating this point one. Next important point is that whatever may be the compounds which is formed by the formation of your ionic bonds are known as an ionic compounds one. So obviously here the ionic compounds conduct the electricity in water or the molten state one. Okay, this is another important property of your ionic compounds one, or the you can in short consider it as an ionic bond one. Next, generally the ionic compounds are water soluble compounds one. Okay, for example NaCl, it can be dissolved in the water one. Next, fourth important property, they have a high melting point and the boiling point one. If we find out the melting point and the boiling point of this particular ionic compounds one, it is found to be little bit larger than its usual values one. Next, fifth, they have a large charge separation one. Now you know that sodium lose its electron and it have a 1 plus charge one, while the chlorine gains the electron and it will have a minus charge. So there is a charge separation. One atom will have a plus charge, other will have a minus charge. So they have the charge separation one. That's it. So these are the few properties of you. So now in short, if we have to summarize this particular topic, it is very simple one. You can summarize in 3 to 4 points. The first important point is that participating atom must have large electronegativity difference. Electrons must transfer while formation of your ionic bond. Okay. Next important point, ionic bond is nothing but the attractive force which is developed between the positive and negative ions one. Okay, due to the transfer of the electrons one. So this is about a simply ionic bonding, or it is also known as an electrovalent bonding one. So thanks for watching this video. See you in my next video.